Okay, so that was the equation of that graph. So like we spoke about yesterday, you have two asymptotes. The one asymptote is the x one, right? And then you have your y asymptote. And we remember that the x asymptote changes its sign. So the sign in the equation is different from the sign of the actual asymptote. So that's x plus 2, so the asymptote is going to be a negative 2. But then the y one keeps its sign. Sorry. So if it's a negative 3, there is going to be negative 3 equation of the asymptote as well. Okay. Are we fine with the two asymptotes, guys? For the y-intercept, you just take the equation of the graph, and you can just do this on the calculator if you want to. You just make x equal to 0. So that's going to give you a half minus 3, which is negative 5 over 2. That one comes up on the calculator, but this is just negative 2.5. Okay, so if you want to, you can write it like that. It is easier in terms of the actual drawing. So you can just say 0 and negative 2.5. Or negative 2.5, even if you want, that's also fine. For your y-intercept. So guys, I think finding the two asymptotes and the y-intercept, those are quite easy things to do, right? As long as you just remember that for the x asymptote, you change the sign, and the y asymptote, the sign stays the same. Those are two marks that you can get very easily. Okay, and then for the y-intercept, that's also easy. You just remember to make x 0. And then you can literally just type it in on the calculator. All right. And if you just draw those three things, the two asymptotes and the y-intercept, that's already 3 marks out of the possible 5. Okay. Finding the x-intercept is a bit more complicated. So I'm just going to show you my steps, okay? Your steps are a little bit different. But you obviously have to make y equal to 0, right? So you take your whole equation, make that equal to 0. The minus 3, you're going to move over to the other side. It's going to become positive 3. Then you multiply the other side by x plus 2. And then, like I said yesterday, you can multiply the 3 into the bracket if you want to. But it's quicker. You just move the 3 over to the other side straight away. So you're going to put 1 over 3. And then next step, you're going to minus 2 from that. Okay, so you're going to do 1 over 3 minus 2. And you get negative 5 over. Now this, negative 5 over 3, is negative 1 2/3 in terms of drawing. Okay. It's easier if you have it as a mixed number there. Negative 1,666. So you can write it like that. I didn't? Oh, there. Okay, so at that point, we have 4 things, right? 2 asymptotes and 2 points. So just plot those 4 things. Remember, guys, I told you plot them first, then see if you need to find anything else. So there I have my x asymptote, right? X equals negative 2. There is your first mark. There you have your y asymptote. Y equals negative 3. That is your second mark. You plot your y-intercept at negative 2.5. Okay, so that's 0, negative 1, negative 2.5. That is your third mark. And that's the easy one, right? That's the one that you just type into the calculator. Then you plot your x-intercept. Sorry, this quite small there, but that's negative 5 over 3. So negative 1 2/3. Okay, that is your fourth mark, right? Now, as you can see, we have 2 points on the same part of this graph. Okay, so this is now one of those cases where you actually have to find the point on the other part. Okay, so now you need to look. My x asymptote is at negative. So I have 2 points that are bigger than negative, right? So now I need to choose an x value that is on the other side, so that's smaller than negative. Okay, so I decided to go with negative 3. You can do any number that's smaller than negative. Doesn't matter. I went with negative 3. I'm just going to show you on the side. Guys, here we go. So you would choose any x value on the left hand side of x equals negative 2. So I decided to choose negative 3. And this you can also just type into the calculator, guys. You don't have to show this. Remember the equation was 1 over x plus 2. So now x is negative 3. Right? Negative 3 plus 2 and then minus 3 from that. So that is just in the equation of the graph. And you get the point, the y here. Okay, so that is then a point on the other half of the graph. So you can what the graph looks like. So now guys, you might have started a different x value, a different value here, you might have chosen, that's fine. Then the point that you're going to plot for is the point that you plot. Okay. Doesn't have to be the same as mine. And another thing is, if you are unsure about this choosing an x value thing, please don't stress about it, as it's 1 mark out of 5 or 6. Okay, it's really not the end of the world. You can still get your shape mark. Remember, shape is the last mark that you'll get for this one. And the shape mark is for having the curved part, but also having for 2 parts of the graph. Sorry, also for having 2 parts of the graph. So if you have that half, right, I think we all know what our hyperbola has to look like, then the other half is going to be there. Okay, so you can just draw a curve. Alright, you don't have to get full marks, you have to have that one. But you can still get your shape mark if you just draw a curve there, opposite this one. Okay, they're always like diagonally opposite. Right, so if you are stressing about this, choosing an x value, which value you must choose, don't worry about that, just draw your shape. Okay, let's quickly talk about the domain and the range graph. We haven't discussed that yet for hyperbola. Let's see, where can I show it in? Okay, so the domain, we know that that is the set of all the x values. So if we're looking at this graph, x, remember we're looking at the x-axis. Okay, so we're looking at how far is it going to the left and how far is it going to the right. Okay, to the left, we have an arrow. Is that through there? So that's going to go to negative infinity. To the right, we also have an arrow, so that's going to go to positive infinity. Okay, so it looks like negative infinity to positive infinity, but does the graph ever touch this asymptote? No. Okay, so we're going to say from negative infinity to positive infinity, but just not at negative, at the asymptote. Okay, so we're going to write it like this, guys. X is an element of negative infinity to positive infinity, semicolon, x is not equal to negative 2, whatever your asymptote value was. Okay. Remember, an asymptote is something that the graph can never touch. So this will always be from your asymptote. Like whatever your vertical asymptote was, say x cannot be equal to that. Okay. Or what was the other way in which you could write this? Yes, x is an element of real numbers. And then you also just have to say x cannot be equal to negative. So the range is very similar. Remember that range is all the y values. I'm just going to go back up to the graph quickly. And kind of see it here. So for the range, all the y values is going all the way down. Remember now we're looking at the y-axis. Okay? It's going all the way down to negative infinity and all the way up to positive infinity. But again, there's one y value here at the asymptote that the graph can never touch, can never be equal to. And it was y equals negative 3 for this one. Okay, so we're going to have the exact same layout. Again, we're going to say y is an element of negative infinity to positive infinity, but y cannot be equal to negative 3. Whatever your y asymptote was, that value. Or if you prefer, y is an element of real numbers, and y cannot be equal to negative. Okay, so the y value here, this is from your horizontal axis. Whatever that axis was, whatever that value is. Okay, I'm going to show you how to find the axis of symmetry, because that's another thing that they can ask you. They often ask it as like a, after you've drawn the graph, they'll ask it as like another question. So I'm just going to write AOX, okay, axis of symmetry. Now guys, remember there were two, right? We summarized it yesterday. I'm going to write down like the standard form of those two. So the first one was y equals x minus p plus q. You have to memorize this, guys. This is never going to be given. Okay, you have to remember this. Now the x minus p is your denominator. Okay, so what is the equation of this graph? This was the equation of the graph. 1 over x plus 2 minus 3. Now the denominator is x plus 2, right? And your q value is minus 3. So you're literally going to take x plus 2 minus 3. Okay, that's what you're going to do. You don't have to calculate anything else. You're just looking at the equation. This is x minus p, and that is plus 2. Okay, x plus 2 minus 3. X plus 2 minus 3. And now, obviously, 2 minus 3, those are numbers. We can work that out. We have to. So y is equal to x. And then what's 2 minus 3? Okay, so y is equal to x minus 1. That's the one axis of symmetry. The second axis of symmetry is similar but a little bit more complicated. I don't know if you guys remember from yesterday, but we're going to say negative, and then we have our x minus p in brackets, and then plus q. Again, you need to memorize this. Okay. So we're going to take our exact x minus p, the same denominator and the same plus q. But now for the x minus 3 for the denominator, I said x minus 3, I meant x minus 2, sorry, that denominator. You have to just put it in brackets and put a minus. Okay, so you guys see it's the same thing from the other one. Okay. And then our plus q was negative 3. You get that from the equation, straight from the equation. We have an extra step here. We're going to have to multiply this negative 1 into the bracket, which we obviously didn't have to do here. So we're going to say negative x minus 2 and then minus 3. And then we must just simplify that. That's negative x minus 5. So those are the two axes of symmetry. Now guys, what type of graph does this look like? Both of them. Because that's an equation of a graph. A straight line, hey. Guys, remember y equals mx plus c. Right? These are two straight lines. Because we might have to draw these at all, so we need to remind ourselves how that works. So these are two straight lines. And now we haven't spoken about this in a while, but the standard form of a straight line equation was y equals mx plus c. The c value, one that's just a number, was the y-intercept. Can anyone remember what m was? Gradient. Now guys, if your m value is positive, right? If your gradient is positive, you're going to have a line that looks like that. An increasing line. So have a positive gradient, so it's going up. Now that is what we have for the first line. You guys see that my m value here is 1, positive 1. Okay? So this one is a line that's going to look like that. And then if your gradient was smaller than 0, was negative, then you have what we call a decreasing line. Right? A negative gradient is going down. And guys, the second axis of symmetry will always be one like that. We'll always have a negative gradient. Okay, so the second one is going to look like that. Okay, so that is what happens with a hyperbola. We always have two axes of symmetry. One with a positive gradient, which is this one, and one with a positive gradient, and one with a negative gradient, which is that one. Okay, but we might still have to draw this in. So I'm just going to write them. Let's go back to the graph quickly. What were those two equations? It was y equals x minus 1. Hey, x minus 1 and y equals negative x minus 5. Oh, sorry, that's your screen. Okay, now guys, we don't have to do a lot of calculations to actually be able to draw this. All we need to know is that this is the y-intercept, right? Negative 1. The c value is the y-intercept. So you're going to go on your graph, you're going to go to negative 1, and you're going to pull off a point. Now, your graph might not be drawn perfectly to scale, which is actually the case with mine. It isn't drawn perfectly to scale, so it might not work out perfectly, but it's fine. Now, guys, the axis of symmetry is going to go through that point, right? That is the y-intercept of this line. So it has to go through negative 1. And then it's also always going to go through that point where the two asymptotes meet. Okay, always, always, always. So you can take a ruler and you can actually connect those two and just also do like a dotted line. Let's see. So I'll make mine dotted just now. And then you must just write that equation on either side of either of those two arrows. I'm just going to freeze here while I do my dots quickly. Now, I don't want you to panic. It's very, you really don't often have to draw this from. They just ask you for the equations of them, but we do have to do them ourselves. Okay, now guys, if you are looking, like I said, mine is not drawn perfectly to scale, but if it was drawn perfectly to scale, right? And you actually took your page and you folded the page onto that dotted line, the two halves of your two parts are supposed to like fit perfectly on top of it. Okay, this line that we just drew in here is supposed to cut the whole graph in half. Right? So we have one over here. Now the other one is one that I think is a bit more obvious to see. It's going to be a line going here, which makes a bit more sense, okay? Because if we take our page and we fold it on this line, then that part is supposed to fit perfectly on top of that part. Okay, we are going to draw it in now. What was that equation? This one. Then y equals negative x minus 5. So now again, oh sorry, wrong one. Now again, we're going to just put our y-intercept, which is negative 5. Okay, so on your y-axis, and guys, you don't even have to label these points. Okay, don't even stress about that. It's just a dotted line. On this, we need to go to negative 5, which I suppose is over there somewhere. And again, it's going to go through that point where the two asymptotes cross. I'll write that down just now. Okay, again, you're going to draw a dotted line for me there. Focus line. That's very skewed. Let's see what it is. Oh, no, this is going to make a curve. Okay, I need to just turn my page. Sorry. Okay, something like that. Here we go. We just need to make this one dotted. Again, you must just write the equation of that axis of symmetry on it. Dotted. Okay, there we go. Okay, so two axes of symmetry. Now, guys, I don't want you to feel like, oh my gosh, there's so much going on the hyperbola. The hyperbola is the thing that you drew for. Okay, with your two asymptotes, your y-intercept, your x-intercept, and then possibly another point if you need another one. Okay, the axis of symmetry, you just do those lines if they are asking you to in a question. All right. Now, I just want to also write here. So for your axis of symmetry, you are going to do your y-intercept, and then these lines always go through the point of intersection of the two asymptotes. Okay, so when you have to draw them, you're going to look for your y-intercepts, which are just your c values, which you can expect from looking at those equations, and then the point of intersection of the two asymptotes. Right, so literally where those two asymptotes cross. We're always going through that. Okay, I am now going to give you guys two hyperbolas that you are also just going to draw, but then I also want you to do that as the axis of symmetry of both of them. Okay, so just so you can practice that. I'm going to just write down the equations. So this is classwork. You have about 35 minutes, so I think you should be able to finish. I know you guys are very busy in the afternoon. Thursday. Yes, I'm going to write here. All the following hyperbolas and the equations are equal. The axis of symmetry. Okay, so the first one is the first equation, and then the second one now, guys, for the second one, just note that there is a minus here in front of this fraction. Okay? Now, all that does is if we're looking at, I'm just going to go back up to the graph here quickly. This one had positive 1, right? We said that the A value basically is positive 1. So the graph was in the top right block and the bottom left block. Okay? Now, when your A value, when your fraction is negative, you're going to do the exact same calculations and everything, but when you plot your points, it's going to be in this section and that. Okay, so it's just like in different blocks. But it's not, you don't really need to know that. You're going to get your points and plot them, and then you'll see. Okay, so the minus doesn't like change anything hectic. You don't have to stress about that. Just remember when you are now like doing calculations, because obviously type in that minus in a calculation, right? Or when you're solving for x, your fraction is going to be negative. It's going to follow all the same steps. And also when you're doing your axis of symmetry, you're not even going to bring that minus into it. Okay, axis of symmetry is always your denominator and then the two values. Right. You're not gonna, that minus doesn't change either of those formulas. Okay, you can get going on that now. I have about 2 minutes still. Just quickly, how far you can get, yeah. I do, yes.